Hello guys, so we're going to solve this beam. As you can see, it is all hinged using the slope deflection method. And remember, for the slope deflection method, you're going to have to find the fixed end moments, then the slope deflection equations, the equilibrium equations per joint, and lastly you're going to have to draw the diagrams. That is the shear force diagram, fixed end moments diagrams, the free end moment diagrams, the end moment diagrams, all of those diagrams. But before we start that, the best, I didn't write the question here, but basically this is the beam that we're solving, and we want the B part from the analysis from the question. The B sinks by 5 millimeters. That is towards the right. That is, then the C also sinks by 2 millimeters. But then you have to convert these to meters to work on a standard SI unit, basically. Then the fracture rigidity, when you calculate it, since the values were given in millimeters, you make sure to change that to meters. You get it? To meters squared. And for this kind of a question, if you're unable to change the units correctly or manipulate the values correctly, then the entire number is going to be failed. So after you've converted them, that's the first part, which is the conversion, and you found the settlements in their right units. That's when you're going to calculate the fixed end moments. And I've divided my beam into three parts. That is the span AB, where I've calculated it, the fixed end moment, and also span BC and span CD. And for the span BC, you have to find the net settlement for you to be able to manipulate the whole equation and be able to find the fixed end moment, as you can see there. Then after that, we're finding the slope deflection equations. But remember, when you're finding the slope deflection equations, the moments at BA, no, at the moments at AB is equal to 0, and also DC is also 0. Since those are hinged ends, so they do not have a moment. Bear that in mind. So after you've put in these values into the fixed end moments, the fixed end moments, I mean values into the slope deflection equation, you have to work for the equilibrium equations. And we're going to start by joint B. At joint B, we have the fixed end moments at BA plus the. Sorry, my camera has been misbehaving, but have restored it. So let's continue. After that, you have to calculate the equilibrium equations and manipulate them for each of the two joints, that is joint at B and joint at C. So when after you have generated the equations, at least at this stage you should be having four equations as I've manipulated them here. So you ensure to solve those equations in by elimination method. Someone might use substitution here, but then I think substitution and elimination, it will be best to use elimination here because it's easier to work with compared to substitution. After you found the, the EI theta values, you're going to make sure you substitute them back into the values of the slope deflection equations to be able to find the moments at each point. Now, this is an optional stage. After this, you can either go to start working on the shear force values, but to save time in a structural, pardon on the noise in the background, that's my neighbor. For you to save time in a structural analysis paper, I would advise that immediately you're done finding the moments, go direct for the end moment diagram. These ones are wrong, but you have to start with the end moment diagram. And after you've drawn the end moment diagram, go for the free moment diagram. You just find the moments. Yeah. After finding the moments, you draw. At least those two will be able to fetch for you some time, like buy for you of time that you would have used to calculate the shear force values. In case time is running, at least you have reached somewhere that you'll be able to get marks. And you even draw the final bending moment diagram. And I know it might look a bit disorganized, but I feel that is better for you to be able to save some time and get some marks out at the end of the day. Then the shear force values, you calculate them as last. As you can see, mine were calculated here. You calculate the shear force diagrams. I'm just trying to buy space, that's why my work is kind of crowded. But yeah, you calculate the shear force values, then you'll be able to plot the shear force value diagram. You have to label them. I didn't label and I didn't shade through, but you have to do that to have clean work. So go ahead, like, subscribe so that you don't miss any of my simple explanations. Bye.